Morning, everybody. It is grade 6, module 5, lesson 1. This is just the intro. Now, the problem set is going to be on a different video because there's a lot of things that go into understanding the concepts of module 5, and lesson 1 introduces them. And that goes back to the basics of our polygon learning the rules of what makes different shapes or polygons called those things. So you may want a journal and a pencil or something to write with so that you can take some notes, draw some pictures. Lots of pausing in this video and writing stuff down would be very helpful for you. And then I'll have another video called Grade 6 Module 5 Lesson 1 Problem Set to go over the exercises and the problem set. All right, let's get to it. All right, everyone, let's start with some review of some terms and rules that help us solve for problems of area and when we get to surface area as well as volume. It all kind of starts with the basic rules of polygons that we've learned. And so we're going to start with maybe getting a journal out. I highly recommend if you have a journal, get a journal out, take some notes. Or if you just remember these things really well and you don't need it, then you can refer back to lesson 1. But let's talk about a couple things. We have two triangles, right? Triangles are shapes with 3 sides and 3 angles, but they also have more specific names. This is a right triangle, because when you look at the angles, remember the angles are the area between the corners, kind of where the lines meet, right? Here's the vertex, and then you've got these 2 lines coming off of it. They form a mouth or an angle here, and then these 2 lines form this angle, and these 2 lines form this angle. And so we're always looking at the inside of the shape, those angles. And so if it makes a perfect right angle, an L, this is 90 degrees, right? Then we call it a right triangle, no matter what, right? No matter how long the sides are, no matter what angle the other ones are, if there is a right angle, we call it a right triangle. And then we can also look at the sides, right? And so we can compare, are the sides all the same? Are they all different? Are there 2 the same and just 1 different? And in this case, they are all different. This is our shortest side, this would be our next shortest side, and this would be our longest side. And so we call that a scalene. Scalene triangles have all different sides, lengths. So this is a right scalene triangle. And some rules to write down. And feel free to pause this at any time. All triangles, when you add up their angles, will equal 180 degrees. So we can say that this is 90, right? Maybe this would be this. These look pretty much the same, but they're not the same. Maybe they are the same. I don't know. We'll say these are both 45. So if this is 45 and this is 45, that'd be 90, and then this is 90, that'd be 180 degrees. And you can imagine that if I took this line and I unfolded it, and then I took this line and I unfolded it, I would make one straight line, and a straight line is 180 degrees. Okay, let's move over to this triangle. It is acute. So again, we're going to look at the angles first. Okay, you look at these angles. None of them are as big as a 90-degree angle. And an angle that's less than 90 degrees, if you remember, is acute. So all 3 angles are less than 90 degrees. We call it an acute triangle. Now, I'll notice that all these sides look to be the exact same length. At least I assume they're the exact same length. I haven't pulled out my measuring tape. But we're going to assume these are all the same length. And so this is an equilateral triangle. That means all the sides are equal. So again, pay attention to the difference between these triangles because they will have a few different rules when it comes to finding things like area or perimeters the same. But right triangles have a couple extra things we can use, and acute triangles require you to do a few different things in order to find area. So moving on from triangles, let's go to parallelograms. Well, this isn't one, but these 2 are. And more specifically, all 3 of these can be categorized as 4-sided shapes. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. We call those quadrilaterals. So all 4 of these are, I'm getting all mixed up. All 3 of these are quadrilaterals because they each have 4 sides. Now, they have specific names. This one is known as a parallelogram. A parallelogram is a 4-sided figure that has 2 sets of parallel sides. So you can see the top and the bottom and the right and the left are parallel to each other. All right, so the top and the bottom are running parallel and the right and the left are running parallel. Angles don't matter, right? As long as it has two sets of parallel sides, it is called a parallelogram. Hence, when you come down to this one, which most of you are like, oh, it's a rectangle. It is a rectangle. You're right. It's a quadrilateral because it has four sides. It's a rectangle because not only is it a parallelogram, because it has two sets of parallel sides, it also has four right angles. And that's what makes it a rectangle. It's a parallelogram with four right angles. So this is only a parallelogram. This is a parallelogram and a rectangle. But then when you come over to this quadrilateral, you don't have two sets of parallel sides, do you? You have one, right? This is one set, a set of two. But these are not parallel. If these were to continue, they would eventually run into each other. And parallel means it's going in the same direction forever and will never touch. So this quadrilateral has a special name of a trapezoid. Now these two aren't on here, but it's good to understand the difference between them. So we were noticing with the quadrilaterals that as long as they have four sides, they're called a quadrilateral. So if you look at the outlined shape here, oh, hang on. This has four sides, and of course this has four sides, as well as these three. So these are also quadrilaterals. Now a parallelogram just has to have two sets of parallel sides. So that means that both of these are parallelograms, because this has two sets of parallel sides, and this has two sets of parallel sides. Okay, so they're both quadrilaterals, they're both parallelograms. Now, this one, remember the rectangle was a parallelogram with four right angles. So this is a rectangle as well. This is not a rectangle because it does not have four right angles. All right, but this shape has a special name. On top of being a quadrilateral and a parallelogram, because it has two sets of parallel sides, and a rectangle because it has four right angles, they also can call it, that's right, a square. And a square is all of those things, but it also has all four sides as this are equal. They are the same. Okay, but that also gives it another name, all right, which is the name of this shape. You'll notice this shape as a quadrilateral and a parallelogram is not a rectangle because it doesn't have the four right angles, or a trapezoid because it's parallelogram, but it's not a square either because it doesn't have the rules of a rectangle, which is the four right angles. So to be a square, you have to have a rectangle and this shape put together. But what it does have from a square is that all four sides are equal. So that must be a rule in itself, and it is. That is called, that's correct, a rhombus. All right, so now to put all the pieces together, we have one, two, where'd it go? 1, 2, 3, 4, 5 quadrilaterals represented here. There is one more called a kite. We're not going to talk about it though. And this is the only one that doesn't fit into these four's category of being a parallelogram, but they are all quadrilaterals because they have four sides. Now, a parallelogram only has to have two sets of parallel sides. So that means this is a parallelogram, this is a parallelogram, this is a parallelogram. They all have two sets of parallel sides. Opposite sides are parallel. Then to be a rectangle, you have to have four right angles. But they don't care about how long your sides are, right? Just four right angles, which makes this a rectangle because it has four right angles, two sets of parallel sides. So it's a parallelogram, it's a rectangle, it's a quadrilateral, but it's also a square because it is also a rhombus. And so a rhombus is a parallelogram, which is a quadrilateral, and has four sides that are the same length. So this is a rhombus. And then it's a square because it combines the rectangle, the rhombus, the parallelogram, quadrilateral, everything in one special shape is called a square. So to be a square is not an easy task. You have to have all the rules of parallelograms, rectangles, and rhombuses thrown into one. So I put it in the center. Pretty cool, huh? So the last thing I'll do on this video, I'll do the problem set on a different video, is to talk about how to find the area of a parallelogram. So a parallelogram is just like a rectangle, right? Except it doesn't have 4 right angles. However, if I were to, let's say, lean it over to make right angles, would I not have a rectangle? So we're going to use the same concept as a rectangle, but it's a little different because technically this line and this angle are not the same as if I were to make it right. You'll notice the height of this parallelogram is only 4 centimeters. But the length of my diagonal lines, which you know would usually be longer because they're pulled at a bigger angle, so it makes the side a little bit bigger as well, is 5 centimeters. The good news is I don't care about these diagonal sides. All I really care about is base and height. So the formula for area of a parallelogram is base times height. And you might just see BH, right? Base times height. So we're just doing 6 times 4 here, which is 24, and that's going to be centimeters squared because we're actually making a 4 by 6 grid like this. And there will be 24 squares in there, and they will all be 1 centimeter by 1 centimeter. So we call those units centimeters squared. So B, what would that be? The base is 25, right? The base is the side that is 90 degrees to the height. So it's 25 times 8, which is going to be 200, and that's meters squared. And the last one, right? The base is 12. The height is 90 degrees to the base, so it's 7. We don't care about that. So base times height, 12 times 7, is going to be 84, and the units are feet squared because it's going to make square feet since we're using that unit.